How's it going, guys? My name's Brian. I did the bomb calorimeter report. We'll go through a little introduction. So PAR oxygen bomb calorimeter is designed to measure the heat given off by the combustion of a material. This is a widely accepted method by industry. They use it to basically get the caloric values off of food and different substances. The objective of the lab was to understand the physical principles, procedures, and the techniques for using a bomb calorimeter. And we wanted to find the gross heat of combustion of the thermal capacitance. So the theory is pretty simple. If you've taken thermo or heat transfer, it's pretty relatable to that. You see that little equation down there is basically the heat energy is equal to the mass times the specific heat times the change in temperature. The whole idea behind it is you're going to ignite a fuel sample in a bomb calorimeter. When you do that, it's possible to observe the amount of heat transfer by measuring the temperature of the water after combustion. So basically, you can do some sort of energy balance, so you know that all the heat has to go somewhere after you ignite a fuel source, so you can account for that heat change and the change in heat in like the water and all the different things, and basically cross your T's and dot your I's and figure out exactly where all that energy went, and then use that equation there to figure out exactly what the heat of combustion was. That's basically kind of what I just said. You account for all the mass in the system, and the change in all the energy would basically just make it easier for us to account for all that. And the thermal capacitance is pretty easily found if you just manipulate the equation. You just move the delta T over to the right side, and then that gives you your thermal capacitance. This is important because it's absent of any mass, so you can basically just look at that and understand that for whatever substance you're looking at. This is the apparatus that we use. All the parts are here kind of labeled. There's an igniter. Obviously, you want to blow it up. The main component is that stainless steel bomb there, the water. Right here. Everything else is basically just data acquisition, setting the fuse up. It sits in this big jug. The stir helps distribute the heat a little bit better so that you get better results. And that is a pretty straightforward system. It's kind of finicky, actually. Here's the data for the benzoic acid. It's the temperature versus time. And you run kind of like almost like a baseline here, and then you can see right here is when we detonated it and it started to grow in temperature. And I didn't actually take these aren't seconds. The data points I think were taken every 2 seconds, but I'm not 100% sure. Here's the calculations for it. So basically I just found the heat of the reaction by multiplying by the mass of the acid sample times the specific heat there. And once I came up with that, I found out that that was the total energy from the reaction. If you set that equal to all the other mass that you have present in the system, you have the calorie, or the energy of the calorimeter, plus the energy absorbed by the water and the energy given off by the fuse. And you just kind of plug all those numbers in, and you get solved for the energy of the calorimeter, and then you divide that by the change in temperature, and then you get the thermal capacitance, which was this number here. Here was the data for the gummy that we had. It was a little Coke flavored gummy bear that we cut up. This one's a little bit different. The benzoic acid was actually just a calibration experiment to see exactly where the thermal capacity fell. So whenever we went through and you basically take the Qcal, right, for the calorimeter, which is a known value, and you multiply that by that delta T, you can get, you can get the heat of combustion for the calorimeter, which you can then plug back into the equation and find the total heat for the equation, or the reaction, which is down here, just 17,000 number. And then you can solve for the specific heat, and I found that to be pretty close to what I found online. Comparing the fuels, we have benzoic acid is a more powerful fuel. The reaction produced more heat with a smaller amount than the gummy did. And it's also benzoic acid is very commonly used as a calibration sample. It's kind of like these industry standard. It's what they use to basically baseline everything. Here were the heating values that we found just through the manipulation of that same equation. This one was given, and we just recalculated for the gummy. And then here's just a simple comparison of the heating values of different fuels. Propane is pretty wild. It's a pretty reactive fuel. And then those are the other values. In conclusion, the results are pretty much as expected. It's a really popular experiment. Values that I've found, and I think that the other groups found that were pretty close to tabulated values that I found online. And possible errors, you can be not really precise with your measurements, like with the fuse, or you can have errors with the DAC because it's not mixing up the heat with the stir very well, or there could be some sort of procedure error. But I think overall it went pretty well. Thank you.